Hi, Mr. Richards here. Today we're going to take a look at how to solve multi-step equations. In our first example, we have negative 3 times the quantity 9 plus x equals 33. What we're going to need to do is to distribute the negative 3 to the 9 and the x. And how we can show this, we have our negative 3 times the 9, and we'll have the negative 3 times the x. And I'll write the first one out to make sure we see what's going on, but you're not going to have to do this all the time. So we have the negative 3 times the 9 plus the negative 3 times the x, and that's going to equal 33. Well, then ask yourself, negative 3 times 9 is a negative 27, plus negative 3 times x is negative 3x, and that's going to equal 33. Now, we have it down to a two-step equation. We need to find the value of this x. So we need to first move this negative 27 to the other side of the equation. And the way we're going to do this, what is the opposite of negative 27? Well, it's a positive 27. So let's add 27 to both sides of the equation. That cancels out, and we're left with a negative 3x equals 60. Now, what is the opposite of negative 3 times x? Well, divide by negative 3 on the left and the right side, and x is going to equal 60 divided by negative 3 is negative 20. And that's our final answer. These equations do not ask us to show a check step, but you could. You always start a check step by the original equation. And it doesn't hurt to show when you have time. You make your substitution in. Nine plus negative 20 is negative 11. And negative 3 times negative 11 is a positive 33 equals 33. So you know we're right. So what did we do? First, we distributed the negative 3 to the 9 and the x. And then negative 3 times 9 was a negative 27. Negative 3 times x is negative 3x. And this here is a two-step equation. Then you solve it as such to get your answer, x equals negative 20. Let's move on to another example very similar to this. Here we have 2 times 10 plus t equals 42. Well, again, we can distribute the 2 times 10 and the 2 times t. So 2 times 10 is 20, plus 2 times t is 2t, equals 42. You have your variable with the 2 there, so let's focus on this 20 first. And what's the opposite of a positive 20 but a negative 20? So subtract 20 from both sides of the equation, and you're left with 2t equals 22. What is the opposite of 2 times t? Well, 2 divided by 2. That cancels, and you're left with t equals 11. And if you were to put the 11 back in for t, 10 plus 11 is 21 times 2 is 42, so you would know it checked out. But our answer is t equals 11. Now, most equations we're going to solve, like the equations we just solved, typically have one solution. But there are times when you might have an equation with no solution. There may be times when you can have an equation that's called an identity, where you have every single possible number being a solution. In our next examples, take a look at both the null set, where you have no solution, and the identity when you have infinitely many solutions. And we'll keep this table on the... This is an example of an identity where you have infinitely many solutions. So let's go ahead and distribute in order to solve to see how this works out. We'll have our 3 times 6 and our 3 times negative 4x. So our 3 times 6 is 18. And then we have 3 times, pay attention to that negative 4. Negative 4x is a negative 12x. And that's going to equal negative 2 times 6 is a negative 12x. And negative 2 times negative 9 is a positive 18. One of the first things we want to do when we have a variable on the left side of the equation and a variable on the right side of the equation is to move one of the variables over. Well, we can do that by adding 12x to both sides. And you might ask, well, which one are we actually adding? Well, does it make a difference here? It's weird because this cancels and this cancels, and we're left with 18 equals 18. Well, that's a fact. 18 equals 18. Where'd the variable go? It kind of just went away. So this is an example of the identity where we have infinitely many solutions, because no matter what you put in for x, you could put in 1 or 2 or 3 or negative 1, 2, 3, or any number you can possibly imagine, and you will get the left side equaling the right side. So our answer here is all real numbers. Let's move on. In our second example of this type of problem, let's distribute once more. We have 3 times 4x being 12x, and then 3 times 8 being a positive 24. And that's going to equal 2 times 6x is 12x. And 2 times 12 is plus 24. Well, right away, 12x plus 24 equals 12x plus 24 is an example of that identity down there. Now, could you subtract 12x from both sides again to get 24 equals 24 just to prove it? I would. I would always try to work it out, because the next type of examples we're going to be doing look similar, but you won't be able to necessarily tell until you get to the end. So our solution here once more is all real numbers, because there are infinitely numbers of solutions. Any number you put in for x here will work, whether it's 1, 2, 3, or so on. Let's continue. This is an example where you have a null set or no solution, so it's going to look a little bit like these down here. Let's distribute and see what happens. If we distribute our 2 times 3x, that is 6x. Our 2 times 5 is plus 10. And that's going to equal our 5 times 2x is 10x. Our 5 times negative 4 is a negative 20. And then we still have this minus 4x kind of hanging out. Now, what we need to do before we move anything from one side to the other is to combine the 10x with the negative 4x so we can get this thing simplified. So we have 6x plus 10 equals, again, 10x minus 4x is, again, 6x minus 20. Now when you go to subtract the 6x from both sides in order to simplify this thing, you'll get something similar where that cancels and that cancels, but the difference becomes 10 equals negative 20. And before you start to go, wait a minute, I did something wrong because there's no way that 10 equals negative 20, realize this is one of your types of equations where you have no solution because, well, like down here where 4 equals 0, well, that can't be the case, so there's no solution to the equation. Well, 10 equals negative 20 can't happen, so this is another example where there is no solution to the problem. And no solution is your answer. If we look at one more very similar to this, let's distribute our 4 times 5x to be 20x. our 4 times 3 is a positive 12. We still have this minus 6x hanging out, is going to equal 7 times 2x is 14x, and 7 times 3 is a positive 21. Now, again, before I move anything from side to side, let's combine our 20x with our negative 6x, and that is a 14x plus 12 equals 14x plus 21. Now, hopefully you can see where this is going. If we subtract 14x from both sides, those once again cancel, and you're left with 12 equals 21. Well, 12 does not equal 21, so there's once again no solution. So when you get 12 equals 12, that's infinitely number. Solutions are all real numbers, but when you get 12 equaling 21 or a different number, that's when you have no solutions. Now let's look at solving a multi-step equation with the word problem. The length of Philip's stride when walking is 4 inches greater than the length of Anne's stride. If it takes Philip 5 steps and Anne 6 steps to walk the same distance, what is the length of Anne's stride? Let's set up variables for each person here. Let's call Philip P. Well, Philip's is Anne's stride plus 4 inches. Well, then Anne's stride is just Anne. Now, if we set up the equation, Philip's takes 5 steps. Well, what are each of his steps? Well, each of his steps are Anne's plus 4. Then that has to equal Anne's steps. But she takes 6 steps, and each of her steps are A. Go ahead and distribute. 5 times A is 5A, plus 5 times 4 is 20, equals 6 times A is just 6A. Subtract 5A from both sides, and 20 equals Anne's stride, so 20 inches. So for this type of problem, we said Philip's was Anne's plus 4, Anne was Anne. We know 5 of Philip's strides has to equal 6 of Anne's strides, and we distributed and solved the equation.